Welcome everyone to the 2021 Hackaday Prize Dream Team presentation. We're so excited to hear more from the Byte team about how they've been developing the universal hands-free interface that won the Hackaday Prize Grand Prize last year in 2020. My name is Magenta Strongheart and I'm Head of Design and Partnerships at Supplyframe's Design Lab. We're so excited to be able to support devices like this and open source hardware thanks to our sponsors, Supplyframe and DigiKey, for supporting the Hackaday Prize each year and the Dream Team Initiative, where we're working with Makers Making Change, a Neil Squire Society organization, on developing this device with their community as well. Today, we're so grateful to be joined by special guests Chad Lehman, Director of Innovation for Neil Squire Society, Derek Andrews, Engineer at Makers Making Change, Aranya Kerr, the Curatorial and Adaptive Design Manager at Momentum, previously UCPLA, and Andy Lin, Founder and Director of the Emerging Tech Lab at Rancho Amigos National Rehabilitation Center. At the end of today's presentation, our panel of guests will be development engineer who will introduce the team and the progress they've been making so far.
Thank you, Magenta. Thank you to our guests for being here with us today. And hello, everyone. So yes, we're here for the preliminary presentation of Team Byte. The team includes Cameron in the USA, Eduardo in Mexico, and Charita in Sri Lanka. So, hello, team. The Byte was Hackaday's prize winner last year. Its premise is as simple as it is empowering for users to develop an extremely affordable, safe, and responsive hands-free interface. Cameron did a fantastic job developing this project, and now that he is working together with a team of very talented people, the Byte is only getting better. So I am really excited to pass the microphone to the team. The floor is yours, Team Byte.
Thank you, Giovanni, for the introduction. Maybe Cameron want to introduce himself a little bit.
Sure. So I'm Cameron Meredith. I designed the original Byte. It started actually quite a few years ago. I was working as a research and development engineer for medical device user interfaces. And I had a cousin who was born with some pretty severe mobility issues. And I started working on this idea with him in mind. And I tinkered around with it and got it to a pretty workable level. But unfortunately, my cousin passed away and I just shelved the project. But then after I saw the Hackaday Prize asking for assistive devices, I pulled it back off the shelf and restarted development and turned it into a very workable, affordable device. And now we're trying to turn it into something that's actually producible. Before it was just handmade, and we're trying to turn it into something that can actually be made at scale. But then also, this team is so impressive. Rather than just try to replicate the original design, we're pushing it a little bit to add some extra functions and hopefully make it even better.
That's right. Well, I will introduce myself a little. I'm Eduardo Contreras. I was one of the selected engineers to be working with the Dream Team here. I'm really glad to be selected. I'm really excited about this project. We have been working for some weeks and we're going to be showing right now what has been done by us and our ideas, and hopefully we have a good feedback or bad feedback, but any feedback is really welcome. We're really happy to be here, and thank you again, Giovanni and Magenta, to make this happen, and also all the sponsors.
Our pleasure.
I'll go next. So I'm Charis Jaivir from Sri Lanka. I'm a robotics and automation engineer, and I'm also really glad to be a part of the team. And Byte is really an impressive device. I think it's going to help a lot of people too. So again, I'm gonna also thank Magenta and Geo and Supply Frame for making this happen. And also, we also do expect a lot of feedback today. Criticize us.
That's right. Okay. So maybe we shall start with the initial phase, Cameron.
Sure. So as is, the Byte is essentially 4 interdigitated force sensing resistors. And I call it the nav wheel that you press on with your tongue to move the mouse around. And then you hold the stem of this device between your teeth, where there's another force sensor, which is used to activate and to click. And so it plugs into the computer and it shows up as a generic USB mouse and can generally do anything a normal mouse can do. So here's a little insight into how it works. It's actually deceptively complex for such a small thing, but you can see over on the left all of the parts, and part of the effort we're going through here is that the board you see, that's completely hand fabricated by me. It wasn't made in a board house. I used a laser and a mini mill and all sorts of things because you can see on the right, the entire design was done in FreeCAD. So I actually used like a principled approach here and only used free open source tools. And we're still trying to do that by moving the board design into KiCad now, but here's where it started.
Well, first we started like working in the first design because it wasn't easy to manufacture. So the first step that we took was to import every single PCB from FreeCAD to KiCad, which is also another open source tool to do PCB design. So now we have all the previous sensor PCBs done in KiCad, which allow us to make Gerbers, which are easy to manufacture in China or any other PCB manufacturer company in wherever you are. So more people now can manufacture this even if they don't have the tools for manufacture PCB. So this is like a really important step for the version 1 and also for the version 2, because in this way we will have a better path to modify the footprints and the layout inside of the sensors. We will have like more flexibility to modify the versions one and another through the different sensor approaches that we are going to be facing. Once we started talking about the version 2, one thing that we wanted to be upgrading was the capabilities of the device. We really like the idea of having more solutions than only one cable to be connected to a computer or to any other device. So we came out with the idea of having a ref inside of the controller. So that would lead us to have different microcontrollers. We were talking about what we wanted. We wanted to be compatible with Bluetooth Low Energy. Also, we wanted to have HID over Bluetooth, like the previous Byte had HID over USB. We wanted to be like over Bluetooth because it's like a common protocol and it's compatible with every operating system or even cell phones or whatever other system you want to be using. Also, we were talking about that maybe the microcontroller that we wanted to be using had to have a good ADC, maybe a capacity sensing thing, and also that could be powered by coin cell. So what that ideas lead us to grab an NRF52 family, which is the NRF52833. Right now we are facing a situation where we cannot find too many chips because of the chip shortage phenomena. So right now we focused on this chip because there's a lot of support from Nordic. Also, there's some core from Arduino. It has USB built in, and also it has Bluetooth low power. And it's lower cost. You can see right here in the screen all the chart that we did, searching for the correct NRF52 chip, and we decided to go for this chip because of the price, of the capabilities, and also the low power stuff, and also it's little size. So that's the idea that we came from, and that we took for the microcontroller, and also the capabilities of having different technologies for doing advertising over RF, so we can connect to other machines in the future. This is like an idea that Cameron had like since the beginning. So now we are facing more. Well, we are capable of doing a controller that can control a computer, but in the future it could control other things that could be working with Zigbee or Thread. So it's really interesting what this microcontroller will lead us to be developing. But right now we are focusing on this part, on HID over Bluetooth lower energy, and also HID over USB, because it also has USB. And then we start thinking and discussing the other ways to evolve the Byte version 2. And well, we started talking about the feedback to the user when the user clicks or whatever, or control the mouse. So Cameron can dig a little bit more here.
Yeah, so there's two functions for this vibration motor or haptic motor. And one is that the Byte is not active and tracking motion all of the time. So what you do is you bite gently on the stem, and this enables tracking, and it will start to move the cursor. So this is so that it's not moving around when you're trying to talk or swallow, or you just don't want it moving. And then the other is a confirmation when you've clicked. Early on, my prototypes did not have any sort of haptic feedback, and it was somewhat confusing to know if you had clicked correctly, especially when like selecting text or things of this nature. So I put in a haptic motor, but it was just a eccentric rotating mass motor, like a pager type motor. But since we're going to be adding more electronics onto the board, I thought this was a good opportunity to move to a linear resonant actuator, like you'll find in the latest flagship smartphones. And it gives like a much crisper, much more controllable feedback. And the driver chip we're going to be using has a library of effects, so you can choose and customize the feedback sensation. So then we're also looking at, in addition to the resistive sensing, we're looking at other sensing modes, both for redundancy and also better tracking through some sensor fusion. So these are just the concept ideas. One is a multi-zone capacitive force sensor built onto the board, and the other is an array or a single chip with multiple Hall sensors for magnetic tracking. And we're doing some testing and development along both these lines right now.
Also, I think it's important to note here, Cameron, that the previous sensor pad had some problems. The first one was the manufacturability. The precision when the temperature changes would lead to a different drift, right? So like in the Nintendo Switch joystick that may, and in sometimes it drift a little bit to the left or to the right, and the mouse just keep moving even when you're not moving the mouse. So I think also it's important to know that these upgrades are for the final user to be more accurate while using the Byte.
So this is a testing framework that Charita actually designed. And it's all put together. Here you can see it on the right, finished testing jig. And this is for an integrated Hall sensor that actually incorporates 5 separate Hall elements. And we're going to build a similar one for our distributed discrete Hall sensor approach. But this is going to be helpful for finding the correct magnet placement, height, and the limitations on the board layout.
Also, this apparatus, I may say, it was programmed all on Arduino. We tried to use a single 3D Hall effect sensor, which has a lot of Hall effect sensors inside, like Cameron said already. But we wanted to explore the possibility of having just one sensor in the middle to see how the magnet is bending, or if it was better to have 3 different or 4 individual Hall sensors each other. So this was the first approach to the magnetic sensor testing, and it all worked by Arduino with the bare metal firmware. It's just I2C. It doesn't depend on any other library. So it is the start. It is the start for a new library that we are gonna be like publishing for doing this magnetic sensing, because these sensors are not that common in Arduino. So I think it's a good approach. Also, as Cameron said, we are moving through discrete Hall sensor PCB, where we have 3 different Hall sensors and we can access them by each other. And we came out with this first layout for the magnetic sensing. So here you can see 3 different digital magnetic sensors. Every one of them are I2C. And also it has the LRI driver included on the PCB. And this is a really cheap PCB because it's only 2 layers and it's really easy to manufacture. And now instead of having like these through holes to solder cables like we used to have in the first version of the sensor pack, we have now a flat receptacle where you can just solder the flat cable that we're gonna be using. And now we're using less wires than we used to, because it's only I2C and 1 interrupt to be reading all this stuff, and also to control the haptic motor, and that's really important because with the I2C, you can control the driver, and then that's when the library of sensations came to life. You need to control by I2C this sensor. Also, we move forward to the capacitive sensing layout as we don't want to have the microcontroller inside the sensor pack, we wanted to have the capacity to digital IC inside of the sensor. And this capacity to digital IC works over I2C also, and also the driver for the driver for the LRI, it's the same really. So this is a different approach that can be working along the FSR material, and this can provide us feedback to correct the drift that can be happening over the FSR. The thing with this board is that it needed to be 4-layer board because we needed to have more ground planes and also 1 shield for the touch sensing. So this is kind of like expensive than the magnetic one, but also includes a lot of feedback. So this is another approach that we are going to be manufacturing later this week. So maybe Charita could continue in this part.
Yeah, so in terms of the sensing approaches, we've sort of looked into the capacitive and the magnetic stuff. All the PCBs right now for the capacitive and the magnetic are based on the original footprint of the version 1. So, after we've finished with all the sensor testing, till then we are sort of gonna stick to that. So, but still, then again, there are more components in the capacitive and the discrete magnetic PCBs than the original Byte PCB. So we have to sort of modify the mechanical design a little bit, not a lot. So first what we did was we sort of moved from FreeCAD to SolidWorks, because at the end of the day, FreeCAD is open source, but SolidWorks, the design flow in SolidWorks is much easier. And also, if we were to do any animations, motion analysis, or simulations, it's also going to be much easier. And also, in case of we have to make a mold or something, that workflow is also going to be much more streamlined in SolidWorks. But by the end of the day, when everything is done, obviously we are going to move everything back to FreeCAD in the spirit of keeping everything open source. So you can see the Byte capacitive one and the magnetic one. The main changes are the new components inside, the new SMD components inside, plus the linear resonant actuator vibration motor that's introduced inside. Can you move on to the next one? So in terms of user experience, I think the silicon enclosure plays an important role in this. So what the silicon enclosure does is it sort of insulates the electronics from the moisture inside your mouth. And it also acts as a layer of comfort for the user because, the 3D printed material is, it's pretty rough. So that's gonna give you some comfort. And also not everyone's mouths are the same. So we hope that with the silicon enclosure, the shape would sort of conform to each and everyone's mouth, if that makes any sense. So also another thing is, can I go back?
Yeah, sure.
Another thing is, since we're using it inside the mouth, this needs to be clean and sanitized all the time properly. And also with the condition right now in the world, people are very conscious about sanitizing everything. So with the silicon enclosure, we can sort of go there. So Cameron originally in the version 1 used a pacifier nipple for this, which worked perfectly fine. But I think with the version 2, the shape, we're trying to keep everything smaller, everything much more comfortable. So I think in the version 2, the shape would sort of change somewhat. So we sort of need a silicon enclosure that would be more customized than the off-the-shelf pacifier nipple. So therefore, we sort of looked into, molding the silicon enclosure. So for this, we sort of tried out 2 or 3 versions of the mold. We did actually 4 versions of the mold, and the 4th version actually was the good one. This should be actually the 4th version. So we sort of like that. Can you go to the next one? So in terms of, well, can you?
Yeah, sure.
Yeah. So in terms of the material that we're going to use, it's going to be liquid silicon rubber, which is what's used to make the pacifiers as well. After thorough research, we sort of finalized on 2 materials, Smooth-On Soraclear 18 and Chemsys LSR 120. So there are several criteria that we had to sort of consider when we're selecting this. So the grade is sort of defined by, grade is defined so that it could be food grade or medical grade. So in which area that you can use that particular material in. So for this, food grade or medical grade would be all right, but I personally do think medical would be better, since food grade is mostly used to mold chocolates and stuff, but medical grade silicons are mostly used to they're designed to keep inside your body. So that would be the best choice. As for the viscosity, the molds were designed to inject the silicon. So for the viscosity, the Soraclear 18 it's pretty thick. It has about 23,000 centipoise of viscosity, whereas the LSR 120 is about 4,000, which is much thinner. So it's Chemsys is going to be easier to inject. And with the hardness, we don't need it to be really that hard, because we don't want to give the user don't want to give extra force to the button. And it's just going to make the thing much harder for the user. So hardness, we sort of finalized on 15A to 20A in the show scale. which is going to be like a eraser, but 2 mm thick. So it's not going to be that hard. So appearance wise, it's we sort of agreed on going translucent because, you know, aesthetically it just be like working time or the pot time is generally workable in both components, and the curing time it's 24 for the both compounds. So either way, we went with the soda clear 18, although ChemSys was the best choice. We went with the soda clear 18 just because of its availability right now. It's with the logistics and everything, and with the condition in the world, it's a bit hard to get everything done pretty quickly. So we need to get this moving fast. So we went with the soda clear 18. So the fabrication was actually done by Cameron. We used a resin printer to print out the molds, and he did the rest of the molding process. Maybe Cameron, you can sort of talk about the molding process a bit.
Sure. So generally, you know, the people on the internet, whoever they are, say a resin print with a platinum cured silicone just doesn't work. But I've been prototyping just fine with the process by sealing the molds with a lacquer first. And this seems to take care of the inhibition that leaves most of these silicone casts tacky afterwards. So, so far I'm having real good success, and it's been, the main concerns that we've had are trying to make sure there's no bubbles in the final silicone component. And so I've had to purchase a better vacuum chamber, and that's helped. And the other part was the flow in the mold to make sure there's no trapped air after we inject it. But finally, this new V4 mold is working quite well. And yeah, other than the overall shape, we might you know, continue to fine tune it, but this approach is certainly working for now. Oh, and the end idea is right now we're just making a separate silicone enclosure, as you see on the right there, but hopefully we can overmold the finished sensor directly in silicone so that it's absolutely sealed all around, and we would save an additional assembly process step. So who wants to talk about this one?
Well, maybe you can start and I can follow.
Sure. So right now in the prototypes, we're using a flat 8-conductor Cat6 cable, and these are very tiny wires after you you know, strip off the insulation. But we're using them to bridge the two pieces of the Byte because there needs to be flexibility between the stem and the sensor. So doing all of these tiny wires by hand is quite challenging. So we're moving to a flex circuit to make the bridge between the boards. And then since we were already going to be using a flex circuit, we're going to do this kind of folded origami approach and save even additional components for the top contacts on the resistive force sensors.
Also, it's important to know that this is like the first idea. We are also waiting for some, well, I'm waiting for, this is already in KiCad. So I can manufacture right now in PCBWay, for example, a flex PCB with this shapeform. But we are, well, I'm waiting for the FSR material, which is the main functionality of the version 1, and to put everything right here in the flex PCB. So in this way, we will have like a little thin layer with all the connections. And also we are, as you can see in the folded flex PCB, it's like really, really folded. Like it doesn't have like one millimeter, well, 3 or 4 millimeters of height. So our idea is to just flex, fold the flex PCB, even if the traces get cut. But the idea is to put some vias exposed where we can do solder joints. So even if the paths of the wires inside of the flex PCB gets cut by default, we can resolder them like really quick for the first prototypes. The whole idea of this is to get an easy path to manufacture these connections instead of having people soldering these cables, and also maybe with the movement get desoldered or get like cut because of the movement. With the flex PCB approach, can be done like in an easy way and just with one only part that can be manufactured in China. And also the idea of this is to provide a better flexibility over the movement. So this is the first flex PCB that we are gonna like testing, but also we are waiting for other designs, well, like a spring design for the flex, so it can fall like better.
Just to clarify on that a little more, these folds violate the normal design principles for a flex circuit. You know, you're supposed to have a very gentle bend radius. And so we're clearly violating that, but then making up for it with these vias
Yes.
To reestablish the connection, just in case that wasn't clear.
Thanks.
So in terms of ergonomics, so this is not, so I think like for the end user, this is going to be very important as to how this should be shaped. The whole thing should be shaped. But right now, again, like I said before, we're going to stick with the version 1 footprint until we get, you know, a bit more confident about the sensing. But then again, it's good for us to think about this one, this particular one too, how the final design should come out. So anyways, it's we hope that I mean, our target is to make it more smaller and much more comfortable and more manageable, and with the end user. So we did a bit of research into this. So you can see a sagittal section of the mouth here. So we sort of finalized that you know, hard palate, the soft palate, and the tongue would be the most affected areas in the mouth by the bite. So if you can see, look at the hard palate, it has a bone on top of it. So it's not that sensitive, but the soft palate, on the other hand, it's pretty sensitive. Even like the middle part of the soft palate is pretty sensitive. So if you like sort of stimulate it somewhat, it gives the user a bit of gagging sensation. So that's obviously not nice. So and also with the tongue, if the movements that the tongue has to make is hard, so it's going to tire out the tongue. And also if the movements are sort of awkward, it's also going to sort of give you a sensation of gagging. So with all these things in mind, we sort of you know, set on this particular shape, which sort of, you know, curves with the teeth and sort of guides along the hard palate. Yeah, so we printed this out, and like everyone in the team sort of tested it out, and with the feedback from the first one, we sort of moved into version 2, where we sort of made a 6-degree sort of angle in the device, so that the tongue could reach much better. And also we sort of like sort of rounded the whole all the edges as well. Actually, one of the interesting things that we found out recently, right, Cameron? This sort of thing, like it's a bit hard to swallow your spit with this particular design. So once we sort of like got into it, we sort of figured out that it's like sort of the rigid shape in the stem of the device. So if that is flexible, that could probably sort of, you know, remove that not being able to swallow your spit issue. Can you move on to the next one? Yeah. So when you talk about the future steps and challenges, then again, the ergonomic shape, that's going to be a challenge to us, obviously. So we need to figure out how the best way we can put everything inside the inside the device and like make it much smaller. So that's going to be a challenge for us, but we are excited to face that challenge. Also, testing with the target audience. So we'd love it if we could sort of test the version 1 device with disabled patients, so that we can get the real feedback from them and sort of get that data into the version 2, and so we can make a much better, much knowledgeable decisions on the design. So that's going to be a huge help. And obviously when the version 2 is done, we have to do the same tests and get to the version 3. So that's going to be one of the future steps that we hope that we could do. And also right now, like Cameron said, we are going with the normal molding process, but again in the future, liquid silicon or rigid plastic, or liquid silicon probably over molding is going to be the best choice, could be the best choice. But again, in a prototyping phase, it's a bit expensive to try that out. So yeah. So another point is the control system, or rather interpreting the sensor data. So like Cameron said, we could do sensor vision. We are trying out several methods of getting the feedback, the FSR, the capacitive, the magnetic, and so on. So if we could do sort of redundant sensor fusion, we can have the data about the same activity from 2 sensors, and sort of make a better decision as to what's the final result should be. And also in case of a failure, we could just remove one sensor and use the other. And also, let's say for an example, we take a magnetic sensor and the FSR. If we can combine those 2 together, the FSR can sort of detect the force that the user is gonna press the button. But the magnetic sensor that can't detect that. Although it can, but it's going to be hard. So we can detect the urgency of the movement that user wants with the FSR, while sort of tracking the movement with the magnetic one. So we can do really a lot of things with sensor fusion method. Also. Actually, Cameron actually drew these figures. He had some ideas on it. Maybe you can sort of explain what goes on.
Yeah, sure. And actually, I think we're just about out of time, so maybe we can open it up to discussion now. But yeah, these are just some sketches that came up during our development effort. The top right one is a potential stack up for incorporating both the capacitive and resistive sensors. Below that is a lower profile option for having the magnets for the magnetic approach kind of pass through the board. And then the other one to the left is playing around with this folded flex approach, again, for the capacitive plus resistive sensing. But I'm actually, super happy to be talking about this project, but your guys' feedback is going to be what I'm most interested in. So yeah, any comments?
Thank you so much to the Dream Team. I'll have you guys stop your sharing.
Yeah, sure.
Thank you so much, Cameron, Eduardo, and Charitha. It's so exciting to just see how many developments you've made in such a short period of time, and we're only halfway through the sprint. So excited to see a lot more on the way as well. Before we have our awesome panel of guests get started with feedback, I'm just going to take a moment to introduce them because we are so grateful for their time today, for their participation in this project and event, of course. One moment, I'm having a... All right, so today we are joined by Chad Lehman, Director of Innovation for Neil Squire Society, Derek Andrews, Engineer at Makers Making Change, Aranya Kerr, the Curatorial and Adaptive Design Manager at Momentum, previously UCPLA, and of course, Andy Lin, Founder and Director of Emerging Tech Lab at Rancho Amigos National Rehabilitation Center. Thank you all for being here, and without further ado, I'll pass it off to you.
Sure. So I'll jump in. Fascinating to sort of follow this as Neil's Score, we've done a number of sort of systems on sort of mouth-based inputs. I guess one of the questions I had around it, and it's a little bit more sort of the less technical. Derek will probably have more technical questions. Mine's a little more user-centered. I'm curious about like, how would this user have this sort of mounted by their mouth or be able to take it in and out of their mouth? Is somewhere like a character is going to put it there and it's going to do that? Or are they going to have the ability to kind of get it in and out? Something that we found with some sort of systems is sometimes the technology is one part, but mounting it in right spot for the person they can easily access with the abilities, sometimes a much more complicated problem than you first think. So I'm just wondering about that sort of like, how do you get it to where the user is going to use it, and are they able to sort of independently engage or disengage with that?
That's a good question. So you could mount it on an arm, of course, like, rigidly mounted arm, or someone could assist, but I've actually built a prototype of a little linear actuator that could actually deliver it to your mouth, maybe on a voice command or something. So far the development effort has been on the sensor itself, but I have been thinking about more of a way to actually deliver it to the user on demand.
Very interesting. Yeah. Because I mean, it, again, depends a lot on the user and what they want by their face, or they want there all the time, right? But that's something that was, on their chair close to them that was able to go that final mile when they want to use it and then get it all the way and they want to have a drink and they're just talking or whatever. It's interesting. A slightly related bit to that, and then I will pass the torch. If I understand correctly, for it to be actuator to use, they do need to sort of close their jaw and bite. And I just was wondering a little bit about that. There's some disability groups I think would really benefit from this, like ALS, perhaps cerebral palsy. There's quite often something known as like drop jaw, where the ability to close their mouth can be difficult. So especially, later progression ALS, that can be more difficult. But this where, you're losing more and more ability to use your body would be a godsend for some people. So there's that sort of trade-off. So I'm not sure whether there's a software bit where people may be able to trigger that on and off another way, but just a consideration for you, because that's something we run into with most systems too, is especially sit with puffs, the abilities to close the jaw can be a barrier for some people with more significant disabilities.
Sure. And also the activation via a slight bite force is mainly to take care of this drift issue that even Nintendo apparently can't fix. So that's why we're looking at multiple sensors, and hopefully this could track motion continuously without the need for an activation. Another approach is that we can detect when there's force being applied to the whole sensor nav wheel and use that to activate it. So you could just push the whole thing with your tongue. This would activate it and then move it around. And when you remove pressure, it could, essentially turn back off.
Interesting. Thanks so much, Gavin. Sounds like you guys have started to look at some of these other sort of constraints outside of just the sensor sort of stuff. I'll pass the torch here, but we've just released some code to look at FSR and drift and mouse movement stuff too. So perhaps from our repository, some things that you can borrow some of our homework. Yay, open source. I'll pass it along. Thanks so much, guys.
I'll jump in, and Chad, I think we were thinking along the same things with the mounting. That's going to be so crucial to the use of this. And I was just working with a person with spinal muscular atrophy yesterday, and he had purchased a quad stick, and unfortunately it did not work for him. I did see your site, and I did see the mention of the quad stick, but for gaming. And no matter where we put it, it was a big challenge because he had really no head movement or any kind of movement, even his mouth. It was a challenge. So yeah, that whole mounting issue is going to be huge. And I know the lip sync has a mounting component to it and has some flexibility to it. And just for everyone's information, Chad, Aragna, we all kind of know each other through different communities. And it's really great to see the work you've done, this team, and to see all the issues that you're looking at. And the issue with secretions is also going to be huge with some forms of disability that is a huge issue, and they need certain people need to be suctioned every now and then. And also with progressive ALS, as Chad mentioned, it could be a challenge to use some device like this because of secretions and also lack of movement in those tongue muscles, and also just in performing like bites. But I think you, Sharitha, you had mentioned about getting this tested with people with disabilities, and I think that's going to be absolutely critical in the design. All the shapes that you're looking at, I think it's going to be really important to get that shape down, as you mentioned, with gag reflexes, with salivary issues, with things like that. So yeah, I think there is potential, and it's great to see the work that you've done in such a short period of time, and looking forward to the next stages of the project.
Hi, Andy. If I could jump in, there's actually something that we wanted to discuss with you, and of course with all of our guests, but especially with you because of the lab that you need. So one of the things that we were talking about in the early stages for fixing the bite to the mouth, I think it was Charita who suggested designing something like a guard that dentists use. And at this early stage, we left it in the back burner because one of the goals is to make this as easy to manufacture as possible. And of course, guards are perfect for fixing something, but you have to custom make them. And we didn't know how difficult it would be in this first stage. So what's your opinion on that? Do you think technology will evolve to make this something easier where someone's mouth can be scanned and then 3D printer, or are we going to still be using the old style where they, put some plaster in your mouth and release, make a mold, make the positive, et cetera, et cetera?
Yeah, I think the scanning technology has really improved. I actually had it's funny you mentioned this with dentistry. I myself have troubles with getting a right night guard, so I grind my teeth at night. So with dental technology, there's new scanners, intraoral scanners that he was able to scan my mouth and produce a mold, and from that make the mouth guard. So I think customizing with assistive technology is really going to be important, and especially with the mouth, how each person has a different kind of shape of the mouth, with the teeth and various the palate also. So I think it's the technology is just getting better to do that. I know maybe about 10 years ago there was a retainer drive system that I saw online that uses magnets. I saw that you did some research into that, but the magnet, I think it was the version 3 of the Georgia Tech system that had a retainer on top instead of external headset. I'd have to check on that. I don't remember exactly, but yeah, with that, I mean, that retainer looked pretty uncomfortable, but yeah, it just shows how the tech is changing and how things can be more customized.
It's still more expensive to make one of those 3D printed customized guards than the old school mold, correct?
I mean, the tech is really coming down in price, like with quite a few dentists. The larger dental clinics have like a carbon, the 3D printer, but some are able to make the molds out of a really inexpensive resin printer, like any cubic photon, which is like sub $200 or so. So yeah, the price is just gonna continue to drop.
Thank you.
See, I'm from Canada, so all mouth guards are just, hockey, right? You get a piece of plastic, you boil it, bite down, and that's what you have. Probably not quite the same detail you guys need, but.
Yeah, I'd like to say that mouthfeel is definitely an important part of this thing because like I found that when I had the thing in my mouth, I was actually doing some testing. And so I've actually sort of made a little prototype and then basically mine is magnetic. And I think what I'll do is if I just share my screen, I can sort of show you what I've been playing around with. Anyway, I'll just go share, here we go. Yeah, so anyway, what I've been using is the TLV 493D magnetic sensor from Infineon. And what I've done is I basically just created a 3D print and then I've just dropped the sensor in here. And then basically I've got on the left here, you can see what looks like a little circular disc. That's actually just a magnet. On the bottom side of that magnet is like a little sort of half sphere. So it actually looks like a bit like an upside down UFO essentially. And the spherical end kind of fits into this little circular area here. And then it kind of rotates around. And then over here, you can actually see the sensing data coming from it. And so as you basically move the swash plate around, you can actually see the graph change for like the X and Y coordinates. But there's also like a Z component because this chip actually senses both X, Y, and Z. So that basically gives it the capability of like, if I press down on, you can see the gray graph on the top, like spiking up as I basically bite on the thing essentially. I'm just kind of demoing it here with my fingers, but you can see it's spiking there. And then as I basically say move to the left, you can see the axes kind of change. And then basically for Y, you can see the red now going down. And then if I move sort of back, it sort of shoots up to the top. So really with this one IC, which is only like a couple of dollars and a fairly simple 3D print, you can basically make a fairly effective little, sensing unit. And it was just something that I wanted to kind of show as something that may be an alternative to some of the other approaches, because this actually requires really just like a couple of 3D printed parts, like just, essentially just two, because the one on the right here is actually just the one without the wires attached. Now, of course, we'd probably want to add other ICs and things later on, so those other approaches that I saw were really good. And but I just wanted to show what I've been working on, just sort of kind of just dabbling, and so anyway, this may be a possible sort of chip to use for this project, and so I just wanted to kind of share that with everyone. So that's I guess that's pretty much it for me. So
Super cool. Thank you. Yeah.
Thank you, Derek. I really
Yeah,
like
I had
that.
something to say. I mean, this is awesome to see, like the development of where you like started to where you are now. And I think we're just like everything that you guys considered is like, it's like we're at the testing phase, and like that's what I'm excited about, because every time you guys talk about it, I just see like one of like our individuals kind of testing it out, and I think that's where we'll kind of see like what mouth affects like how they use it, and that's exciting. I'm just like excited to see like where we are at the testing phase, so.
And one thing you may encounter as you tested on certain people with disabilities is I've worked with quite a few that really don't want anything near their mouth or anything close to their mouth. And Ragnar, you probably have experienced that too. Just the feeling of having something near it. I've had some people with high spinal cord injuries that are appropriate for even like a chin joystick for driving, but they said they just don't like something near them. Part of it is just the stigma, I think, of having them there, and so they gravitate toward more head controls. But again, you're going to deal with different people with different opinions, just like everything else. So just want to let you kind of know about that.
It was awesome to see your version, Derek, and in thinking about, just almost like a menu of bites for different, limitations, different, whether it's cost or access to materials or the individual's preferences and things. That's something I've been thinking a lot as we've worked with different assistive tech projects. I would love to hear maybe from some of our guests how you all tackle prototyping when there's such a wide spectrum, of course, of how this could assist maybe. How do you prioritize what to focus on, especially with this group? I think right now the priority is the getting it, more scalable, and then wanting to have a few more polished units for testing so that we're not putting unfinished units or units that aren't safe for that process, of course. But yeah, sorry, I know that's sort of a difficult, wide question, but what do you guys see as the priorities or the opportunities when it comes to having modularity or options within a device, or how this device fits into some of the other mouth control or interface devices you've worked with?
Yeah, I think it really needs to be driven by user needs. And so really you kind of have to think about what the user is capable of being able to do, and then trying to sort of aim for, the sweet spot, I guess, within that. It's not easy to sort of just come up with a design and then expect the user to be able to use it. You really have to focus on what the user is capable of, and that's something that I've definitely learned over the last few years, is that it really has to be driven from the user side of things, and find out what capabilities they have, and then try to leverage that using sensors that are readily available, and try to make things that, because most of our stuff is sort of open source type stuff, and so we try to focus on things that we can acquire at low cost, and try to use creative ways to combine those things in such a way that we can build things at a low cost, but also have meet the kind of needs of the community. So like, for instance, one of my current projects is essentially a successor to our lip sync project, which of course was the original sort of mouth operated mouse. And if I just grab a mouthpiece here, I'm just gonna show. Sorry. So anyway, this was the original sort of lip sync that we had, and so essentially you just move the mouthpiece with your mouth and sip and puff to do the clicking. And so now currently I'm working on a smaller, lighter version, this is another prototype that I've got. So the whole idea with this one is that it does the same thing, but again, user driven, in the sense that we had feedback that users wanted to have it easier to operate. So the new mouthpiece thing is on a little flexible rubber stock, and it's using the same magnetic sensor as I was demonstrating earlier, and so the magnet here is just kind of in front of the sensor, and as you move the mouthpiece, it kind of just gives you the coordinates, which then feeds into the mouse software to give you a mouse output. And but the thing is, the new version is trying to be more low profile, so users wanted to see more around them, but they also mostly wanted it just to be easier to use, and they didn't really want to have too much in their mouth. And the hard mouthpiece we found was you know, a little bit of a problem. It's that if you know, it's fine for a few minutes or even maybe an hour, but, you know, once you're trying to use one all day long, having that constant thing in your mouth, you really want to have something that's soft and ideally fairly small, so it's, you know, relatively unobtrusive. So I'm still sort of thinking about like the optimum shape for something like, you know, the Byte switch, because, you know, like for a few minutes in my mouth, it's okay. But, you know, after a while, I don't really know how well I'll feel, or whether or not it'll invoke a gag reflex or anything like that. But, you know, I'm, you know, just trying things out at the moment to try to see what might work best. But
Yeah, and I think Aragna and Andy talk about this too. The more people that get a chance to use it, the more input you'll get. People come on a spectrum. What you think is a great solution for one, they may not like for a whole other reason that has nothing to do with your technology in general, right? So there's always that sort of tug of war on different sort of needs and users and perspectives. But I think the sooner you can do some testing, the better. When we did our first version of the lip sync, we built it just off a sort of video game controller, and then a SIP puff interface around it, and it made it quite long. And we found the range of motion of someone's, like, we thought we were done, like, stuff's did, great project, problem solved. I mean, it was video game control, and the amount of range of motion for people was significant. And even a high level spinal cord injury, it was very tiring. There was people that were having real spasms, so it didn't work. So we went more to an FSR sort of approach, like you guys are investigating right now. So, but we didn't know that until we stuck in front of some people and we found out this is not meeting the needs of our intended audience. So the sooner you have some sort of prototype that you can do some trial with some people, the sooner you will learn what you don't know.
Yeah, even just testing the shape, like you had the dummy shapes, I think it's gonna take a while to get the ideal shape, and maybe you have a few different versions of it that you end up with, because one may not suit everyone's needs. It's not going to suit everyone's needs. So just those kind of customization is I think going to be important to have different options available.
Yeah, good thought, Andy. Even, I mean, you know, the scanning and custom to everyone, but then there's barriers, but even like the small, medium, large, right? You think, you know, the size of a child's mouth to an adult male mouth is going to be quite the range. That may be a little bit of a consideration.
Right. One of the huge things I'm noticing in the industry for assistive technology is gaming, with adaptive gaming, and I know that Makers Making Change has a version of the lip sync for the Xbox adaptive controller, but it's something that maybe you want to piggyback on is trying to test this with gaming, adaptive gaming, because there's a huge community like on Reddit and different Twitch streamers that do gaming with assistive technology. So that may be a good kind of place to start and get some traction on. Also, in terms of the name, Derek, you had when you said Byte switch. When we think of the Byte switch, we automatically think of just a simple switch that you bite on. That is just a switch that you hook up to like the ECU or something like that. So something to think about, maybe renaming it something other than the Byte switch, because if you talk about this with people in the professional community, that's what they immediately think of. It's just a simple switch that you bite on.
Actually, I can share that originally I was calling it the bit, and like guiding a horse kind of an idea, but I thought that was a little bit awkward. So it went to Byte, but yeah, that's good feedback. Thank you.
I want to be conscientious of everyone's time here, so just want to check in with the Dream Team. Did you have any final questions you want to ask the panel before we wrap up here?
Okay, well, as things come up, you know, email still works outside of live hangouts like this, right? So as things come up in pieces. But yeah, and I know Derek's working really close with you guys as well, but very curious to get my mouth on one, or get it in front of a few people. Because I think that's going to be your biggest learning opportunity, is the needs of more users to go forward.
Thank you all, and thanks to the Dream Team for their awesome presentation, and of course, our wonderful panel of experts from the assistive tech open source hardware community. We so appreciate everyone for joining us today, and if you want to follow along the Dream Team's journey, check out the Byte at hackaday.io. You can also get in touch with Eduardo, Charitha, or Cameron through that page as well on Hackaday.io, and keep up with upcoming Dream Team events and updates on Hackaday, Design Lab, or Supply Frame's social media channels.